In this module, we're going to look at how we deal when we have compounds dissolved in solution and how we can work out the number of moles we have in a certain volume of that solution. As ever, you can download these slides from the website as PDFs. As we've looked at mole calculations, we've considered solids and we've considered gases as well. Our next task is to look at solutions. So let's say I've got two solutions as shown on the right hand side there. In one solution I've dissolved 15 grams of copper sulfate in 220 centimeters cubed of water, and in my other solution I've got 10 grams of copper sulfate in 100 centimeters cubed of water. I decide to take 20 centimeters cubed out of each. How do I find out how many moles I've got in those solutions? How many moles of copper sulfate do they contain? Well, in order to work that out, we need to look at how we define concentration, and that involves introducing another equation. So we define concentration as the number of moles that have been dissolved in 1,000 centimeters cubed of solution. That may seem a little bit of an odd volume to decide upon. 1,000 centimeters cubed is the same as the old-fashioned 1 litre, but it's also the same as 1 decimeter cubed. And so 1,000 centimeters cubed is equivalent to 1 decimeter cubed. So we can redefine that as the moles per decimeter cubed, and we can show the units as moles / decimeter cubed, as we've shown there. So let's go back to our example. In my conical flask, I've got 15 grams of copper sulfate in 220 centimeters cubed. So we're going to work out its concentration, and its concentration is the number of moles dissolved divided by the volume in decimeters cubed. So we can't use that equation yet. First of all, we need to convert our 15 grams of copper sulfate into moles of copper sulfate, and we also need to convert those centimeters cubed into decimeters cubed. So, molar mass of copper sulfate, I'm sure you're familiar with that by now. That's going to be 159.6. Now we need to find the number of moles. So we had 15 grams, so we have 15 divided by our molar mass, and that really gives us 0.0940 moles of copper sulfate. So we're halfway there. Next we need to convert those 220 centimeters cubed into decimeters cubed, and to do that we divide by 1,000, and that gives us 0.220 decimeters cubed of solution. And then we can use our equation of concentration is moles dissolved divided by our volume of solution, and that gives us 0.427 moles per decimeter cubed. So you may be happy to have a go at example 2 by yourself by following what we did previously, but we'll also go through it step by step starting now. So molar mass we've already worked out, so that's good. Moles of copper sulfate this time is going to be 10 divided by our molar mass, and then we need to convert our 100 centimeters cubed into decimeter cubed by divided by 1,000, so that gives us 0.1 decimeter cubed, and then we divide our moles by our volume to give us 0.627 moles per decimeter cubed. So we go back to our two solutions, and now we can label them with our concentrations. And we can now got to work out how many moles we are taking from each of those. So how do we start off? Well, we know we have this equation. We can rearrange that to now find our volume, which is here in decimeters cubed. So let's do that, and if we rearrange that, and if you're happy rearranging them, you can do that, or you can just learn this equation. The number of moles is our concentration, which we now know for each of them, here and here, times by our volume in decimeters cubed. So our only problem here is our volume is in centimeters cubed, so we need to again convert our centimeters cubed into decimeters cubed. So if we do that for the beaker, first of all, we can find out our number of moles is going to be our concentration times by our volume of 20, and we need to divide that 20 by 1,000 to convert it into decimeters cubed. And if we do that, we find that we have extracted 0.0125 moles of copper sulfate. Can you do the other one? Well, let's give it a go. So what about this one? We've got now a concentration of 0.427. We're going to again times that by 20 over 1,000. And for that solution, we've extracted 0.00854 moles. So we've had two worked examples. Now it's over to you. If you can calculate these again. We've got 9.2 grams of cobalt chloride, and we've dissolved that in 490 centimeters cubed of solution, and we need to find the concentration in moles per decimeter cubed. So you may want to be able to give that a go by yourself completely. If you'd like some help, there are some hints coming up now. So here are some hints. In order to find a concentration, you obviously need to work out your moles of cobalt chloride, and only once you've done that, you need to work your concentration out by dividing that number of moles by your volume, but remembering to convert your volume of centimeters cubed into decimeters cubed. Coming up now are the answers. So molar mass of cobalt chloride is 129.9. So we can find our moles of cobalt chloride by mass over molar mass. Once we've got our moles, we can find our volume in decimeters cubed. So we take our 490 and divide it by 1,000, and then we just divide those two, so the moles divided by the volume, and we will find it to be 0.145 moles per decimeter cubed. So here's question 2. Calculate the volume required to obtain 0.05 moles of sodium hydroxide from a 0.1 mole per decimeter cubed solution. Coming up are some hints if you'd like them, or if not, press pause and you can go straight to the answers. So here are some hints. First of all, you need to know the equation that the volume in decimeter cubed is your concentration times the number of moles dissolved, and your volume in centimeters cubed is equal to your volume in decimeters cubed multiplied by 1,000. So let's go through the answers for this one. So the first thing we are going to do is find our volume that we have in decimeters cubed. So we have our concentration of 0.1, and we know the number of moles that we require. So our volume is the concentration times the number of moles, and that gives us 0.005 decimeters cubed. And then in order to convert that into centimeters cubed, which is far more convenient for us to work in, we multiply that by 1,000, and that gives us 5 centimeters cubed of solution. So that's the first part of solutions. There'll be more videos as we start looking at this in more detail, and we also need to look at titration calculations. But we'll have the next video will be some further examples on dealing with moles in solution.